Welcome back to the deep dive. Today we're tackling something really essential in pediatric eye care: accurate refraction. Specifically, we're looking at how modern autorefractors, or AR, measure up against the classic standard cycloplegic retinoscopy, CR.
Yeah, this is super important stuff. Getting that refraction right in kids isn't just about, clear vision day to day. It's fundamental for preventing long-term issues like amblyopia, lazy eye, which affects, about 2% of children?
Right, and conditions like accommodative esotropia, too. An early mistake can have lasting consequences.
Exactly. So accurate measurement is key.
So the core question here is, are we trading accuracy for speed and convenience with these newer machines? We're digging into a major ophthalmic technology assessment from the American Academy of Ophthalmology, published back in 2020.
That's our guidepost. It's a really thorough synthesis of the evidence.
And it sets up this tension between the old and new guards, right?
Absolutely. The old guard, cycloplegic retinoscopy, it's historically been the gold standard. It involves using drops, cycloplegics, to relax the eye's focusing muscle.
So you get the eye's true resting state.
Precisely. Then the examiner uses a retinoscope, watches the light reflex from the retina, and neutralizes it with lenses. It takes skill, takes time, and, crucially,
A cooperative child. Which, let's be honest, isn't always easy, especially the little ones.
not at all. And that's exactly why autorefractors are so popular. They're objective, they're fast, give you a digital reading almost instantly, and you don't need quite the same level of highly trained expertise to operate them.
Makes sense. So this assessment basically asked, how good is AR, especially cycloplegic AR, compared to that hands-on retinoscopy?
That was the mission, to see if it truly holds up under scrutiny using the best available data.
Okay, before we jump into the findings, talk about the evidence itself. How rigorous was this assessment? They didn't just read a few studies, did they?
Oh no, far from it. The methodology was incredibly strict. They did a big literature search. PubMed, Cochrane, the usual suspects, ended up with 118 initial papers back in late 2019.
118.
But here's the key, the quality filter. They only included studies that met really high evidence standards.
What levels are we talking about?
Level 1, which means well-designed, prospective studies meeting all the quality checks. Or Level 2, which were solid but maybe missed on one criterion.
So only the best of the best.
Exactly. That pool of 118 got whittled down to just 15 studies in the final report. Shows a real commitment to high-quality evidence.
15 studies. That's a focused data set. And what kind of tech did they cover? Was it just one type of machine?
No, it was pretty broad. They looked at data from 13 different commercial autorefractors, 7 tabletop models, 6 handheld ones. And the kids ranged from 3 months old up to 17 years.
So wide age range, different machine types. Pretty comprehensive.
Yeah, they really tried to get a general picture, not just something specific to one scenario.
Yeah.
That gives the findings a lot more weight.
All right, let's get to the results. The big headline, maybe the good news first. How did cycloplegic AR, that's AR wet, compare to the gold standard, cycloplegic retinoscopy, or RET wet, when looking at group averages?
Well, on average, the news was actually very good. Looking at the mean differences, 13 of those 15 top-tier studies found that the average difference in spherical equivalent, or just the sphere, was really low.
How low are we talking?
Less than half a diopter difference, so less than 0.5D. And in most of those studies, it was actually even better, less than 0.25D on average.
Wow, okay. Less than a quarter diopter mean difference.
For big groups of kids, that sounds pretty negligible, statistically speaking.
It really is. And for astigmatism, the cylinder component, the agreement was even tighter. Mean differences were 0.25D or less in almost all the studies they looked at.
So if the averages line up that well, does that mean for things like large population studies, big clinical trials, maybe school screenings, is cycloplegic AR basically good enough to replace retinoscopy in those settings?
For those population level uses, yes. The assessment concluded it's appropriate. Because those small average differences mean the overall data you collect with AR wet is going to be very, very similar to what you'd get with AR wet. It's reliable for large groups. Okay, that makes sense for research and screening. But, and this feels like the big but, how does that average accuracy translate to the individual kids sitting right there in the exam chair? That jump from group data to one specific patient. That seems critical.
This is absolutely the pivot point. It's the, let's call it the aha moment of the whole assessment. We have to distinguish between group accuracy and individual accuracy.
Because the average being close to zero doesn't mean every measurement is close to zero, right? Errors can cancel out in a group.
Precisely. A low mean difference is great, but it hides the potential for significant error in any single measurement. What matters for clinical decisions is the range of potential error for that one child.
Okay, so how did they measure that potential error range? What metric did they use?
They look at the 95% limits of agreement, the LOA. Think of it like this.
Yeah.
If the mean difference is the average daily temperature over a month, the LOA tells you the range between the coldest and hottest temperatures recorded on 95% of those days.
Got it. It shows the likely spread for most individuals.
Exactly. It defines the boundaries within which you'd expect 95% of the differences between the two methods to fall for any given person.
So what did those limits of agreement look like for cycloplegic AR versus cycloplegic retinoscopy?
They were wide. Worryingly wide, you might say. Across the studies, the 95% LOA were consistently broader than plus or minus half a diopter. But let me give you a really concrete example from one study, Paff et al., because it drives the point home.
Okay, lay on us.
So Paff and colleagues found the mean sphere difference was tiny, just plus 0.05 diopters. Almost perfect agreement on average.
Okay, sounds great so far.
But the 95% limits of agreement they reported, they range from plus or minus 3.55 diopters to plus or minus 3.65 diopters.
Hold on, let me process that. The average is almost zero difference, but for an individual child, the AR reading could be off by as much as 3.5 diopters, either too much plus or too much minus compared to the retinoscopy result.
That's exactly what it means. For 95% of kids, the difference would be within that range, but that range itself includes differences up to 3.5D. That's not just a small tweak to a prescription, that's a clinically massive potential error.
Yeah, 3.5 diopters. That could mean misdiagnosing significant hyperopia or prescribing way too much minus power. For a developing visual system, that seems incredibly risky.
It is. An error that large could lead to the wrong treatment or no treatment when it's needed. It could potentially worsen amblyopia or even induce new problems.
So even though the AR technology is fast, and they did get readings on kids as young as 3 months, although, one study needed restraint for about 40% of 1-year-olds.
Still much faster than retinoscopy often is.
Right, but that speed comes with this hidden risk of significant individual error. This seems to be the core reason why retinoscopy isn't obsolete yet in the clinic.
That's the crux of it, yes. The AR gives you a quick number, a starting point. But because of that potential for a large individual error, maybe a 1 in 20 chance of being way off slain, you still need that clinical judgment and often the retinoscopy check as a safety net.
Okay. That leads us to the next logical question. If the drops, the cycloplegia, are what make AR reasonably accurate on average, what happens if you try to cut corners and skip the drops? How does non-cycloplegic AR, or AR dry, perform?
The temptation of dry AR. The assessment gives a very clear warning here. Don't do it. Any time saved by skipping the drops is basically canceled out by the high likelihood of getting a clinically wrong answer.
Why is it so inaccurate without the drops? What's the mechanism?
It's the child's natural accommodation. Without the cycloplegic drops relaxing the focusing muscle, the child's eye will actively focus, often on the machine itself or just fluctuating. The AR machine measures this actively focused state, not the eye's true, resting refractive error for distance.
So it's measuring where the eye is focusing, not what correction it needs for distance.
Exactly. And this leads to a very consistent bias. Non-cycloplegic AR almost always overestimates myopia, makes kids see more nearsighted than they are, or underestimates hyperopia. It tends to over-minus the patient.
How much error are we talking about typically?
Several studies showed it over-minusing by 1 to 2 diopters quite consistently, but the potential error can be much larger.
What were some of the extreme examples they found?
Well, one study flat out called non-cycloplegic AR grossly inaccurate and reported cases where it overestimated myopia by as much as 8 diopters.
8 diopters, wow. Giving an 8D lens to a child who doesn't need it, that could cause serious problems itself.
Absolutely. Induce myopia, headaches, eye strain, you name it. And the other big danger is missing the kids who really are significantly farsighted.
Right, the hyperopes who are at risk for amblyopia. How well did dry AR do at catching them?
Terribly, frankly. That same Paff study looked at sensitivity for detecting moderate to hyperopia, defined as over plus 3.5D. Without drops, the sensitivity was shockingly low.
How low?
Somewhere between 31% and 33.3%.
So, using dry AR, you'd miss roughly 2/3 of the children with significant hyperopia, the very kids you most need to identify.
That's what the data suggests. Relying on a dry AR reading means you're highly likely to miss clinically significant farsightedness.
Okay, the message there seems crystal clear, Dry AR is just too unreliable for clinical decision-making in kids. The drops are essential.
Non-negotiable, really, if you want accuracy.
So let's pull it all together. Based on this comprehensive AAO assessment, what are the main clinical takeaways? What's the final guidance?
The conclusions are pretty straightforward. First, cycloplegia is critical. It massively improves AR accuracy compared to dry measurements. Second, even with cycloplegia, that individual variability, those wide limits of agreement we talked about.
That potential 3.5D error.
Exactly. That means cycloplegic retinoscopy still has a vital role in clinical practice for individual patients. It's needed to confirm the AR reading, especially when things don't quite add up.
When would you say that confirmation is most needed?
The assessment highlights a few situations. Definitely when the AR results seem inconsistent with other clinical findings like the child's history or vision complaints. And crucially, if the child's best corrected visual acuity with the AR prescription isn't as good as you'd expect, that's a major red flag.
It's the essential reality check.
It really is.
Yeah.
Oh, and one other practical point, the assessment found that both tabletop and handheld autorefractors perform similarly in terms of accuracy. The type of machine wasn't the deciding factor nearly as much as using cycloplegia was.
Good to know. Now, looking ahead, did the assessment identify areas where we still need more research? Gaps in our knowledge about AR?
Yes, definitely. They pointed out a need for studies specifically looking at AR accuracy in kids with more complex eye conditions. Think nystagmus or lens problems like subluxation or aphakia, maybe partial cataracts.
Cases where getting any refraction can be tricky.
Right. These kids often need the most precise measurements, but we don't have enough high-quality data on how well AR performs in those specific, challenging situations.
Makes sense. What about outcomes? Do we know if using an AR-derived prescription leads to the same visual results long-term as a CR-derived one?
That's the other big gap highlighted. We need studies that actually compare long-term visual acuity outcomes. Follow kids over time. Group A gets glasses based on AR-wet, Group B gets glasses based on CR, or maybe AR-wet confirmed by CR. Do they end up seeing equally well?
So does the number match the real-world result?
Exactly. Until we have that long-term outcome data showing they're truly equivalent in practice, the caution imposed by that individual variability we discussed remains the sensible approach.
Yeah, that seems wise. Statistical similarity on paper doesn't automatically equal identical visual development in a child.
Precisely. So the final takeaway for you listening is sort of twofold. Autorefractors, especially with cycloplegia, are powerful tools. They're transforming large-scale screening and research, making things much more efficient. But when you're dealing with the vision of an individual child, trying to prevent potentially permanent vision loss, that classic gold standard cycloplegic retinoscopy still holds its place. It's that crucial safety check against the significant individual variability that AR, even at its best, can sometimes exhibit.
Which leaves us with a really interesting, maybe slightly uncomfortable thought to chew on. We have this technology that's fast, objective, great for populations, yet it carries this, let's call it a statistical risk, of a significant error for any one patient, that potential 3.5D swing. The gold standard is slower, harder, more subjective, but generally considered safer for individual outliers. So the question for you is, as technology evolves, how do we balance this? How much individual risk are we, as clinicians and patients, willing to accept for the sake of efficiency? When do we insist on the slower, maybe harder, but potentially safer traditional method, even when the shiny new tech offers an easier path? That tension really sits at the heart of applying new tools in medicine.